Okay. All right, everybody, here's my problem. Let's see, I have y equals, and this is for anybody that just wants an in-depth discussion of example 1 in the book. 3 times the cosine of 4 times theta plus 31 degrees. I think I don't really care for Dr. Forster's explanations here. I think he makes it a little more confusing than it really is. Which, shall we say, as usual, but I don't know. All right, so here we go. First of all, just going to use some simple algebra. Y minus 2 equals 3, of course, times the cosine of 4 times theta plus 31. I got to be careful here. I write small and make sure I have enough room. And then I'm going to take 1/3 of both sides, so 1/3 y minus 2. So get rid of that amplitude, right? Theta plus 31 degrees. Let's see, then I'll take the arc cosine of both sides. So the inverse cosine, and I'm going to take the little c one. So that means that I have to look at the infinite number of possibilities in the solutions, because this is a wave and I'm going to get the same answer over and over again. So let's see, I'm going to take the cosine inverse of 1/3 y minus 2 equals the cosine inverse of the cosine of 4 times theta plus 31 degrees. So I'll just get, when you do inverse functions, I get what's in the argument back out of that. Okay, now let's see. What can I do with this any further to simplify? I don't know that I'm going to do anything more with this right now. Let's see, now I want to know, let's see, find the trigonometric function, find the first 3 positive values of theta for which y equals 1.5. All right, so right now I think I'll go ahead and substitute in, and I'll let y equal 1.5, just to put a different color up here. So it's going to be the arc cosine of 1/3 times 1.5 minus 2 equals 4 times theta plus 31 degrees. And let's see, so I get negative 0.5 there. So doing this on the calculator, now because I have a theta here, I have to make sure I'm going to mode, and I have to make sure I'm in degree mode here. All right, so let me just check that first, and I am. My calculator looks good there. So let me come over and quit. All right, so I'm going to take the cosine inverse of let's see, negative 0.5 divided by 3. Would that be right? Negative 0.5 divided by 3. Yeah, and so I'm getting here, and I'll just round it off, but about 99 point, and forget the minute thing. This is complicated enough. I'm just not going to worry about minutes right now. 6/10 of a degree is how many minutes? It's not that hard to convert that to minutes, but let's just not do that right now. So 99.6 degrees. Now keep in mind here, and maybe I should have even written it over just a little bit here. This is going to be, of course, 99.6 degrees plus 2 pi n. Now let's think about this a minute. Always kind of helps to do that sometimes. Let's see, if I come over here 99 degrees, 99.6 degrees, almost 100 degrees, right? So wouldn't that just be about right there, about 100 degrees, because this is 90 degrees, right? So just 10 degrees past 90 degrees, about right there. Now that is going to have, let's see, 99.6 degrees plus 2 pi n. So yes, I can keep looping around and looping around and looping around there and getting this answer right here, and that's fine. Or let's see, what about down over here? Wouldn't this also have the same cosine down over here? It's going to have a cosine of like whatever that cosine is right there, this x, horizontal x distance. So really it could be or negative 99.6 degrees plus, and what am I saying 2 pi n for? Excuse me, this should be 360 degrees, right? or negative 99.6 degrees plus 360 degrees in degrees equals 4 times theta plus 31 degrees. Okay, well, that's pretty confusing. Oh, not liking my explanation at all. All right, so let's keep going with this for just a minute. So let's keep in mind, what do we have here? 99.6 degrees plus 360 n degrees, okay, or negative 99.6 degrees plus 360 n degrees equals 4 times theta plus 31 degrees. All right, now I'll divide both sides by 4, right? So I'll divide this side by 4 and divide this side by 4, and I'm going to get whatever that is. I don't know. 99.6 divided by 4, I get 24.9. All right, so 24.9 degrees plus, what's 360 divided by 360 divided by 4? 90. I should have known that. Plus 90 n degrees, okay, or negative 24.9 degrees plus 90 n degrees equals theta plus 31 degrees. And now subtract 31 degrees from both disjuncts. So I'm going to get here 24.9 minus 31, and I get negative 6.1 degree, right? Plus 90 n degrees, because I just subtracted the 31 degrees from the 24.9, okay? Or, and then let's see, it's going to be negative 24.9 minus 31. So just subtracting 31 from both of the disjuncts. So I get here negative 55.9 degrees plus 90 n degrees equals theta. All right, now what did they ask you? Find the first 3 positive values of theta. So now I'm just going to find the first 3 positive values of theta. So theta is going to either equal one or the other. I'm going to let n just be some possibilities here, okay? So I'm going to let n be, let me see what, let me get rid of all this because I don't have room and I don't want to rewrite all of that. All right, so the possibilities here now are, let's let n equal, I don't know, negative 1, we could, 0, 1, and 2, and I should find the first 3 positive values in there. So let me see here. So if n is negative 1, if n is negative 1, if I look down here, I'll get negative 96. That's going to be a negative. And if n is negative 1 over here, I definitely got negative. That's no good. All right, if n is 0, they're both still negative, so that's not going to work. So forget that. If n is 1, oh yeah, look. Okay, if n equals 1, I get negative 6.1 degrees plus 90 degrees. That's one possibility. Or I get negative 55.9 degrees plus 90. Just letting n be 1. Either one of those equal theta. So let's see. 90 minus 6.1. Clear. 90 minus 6.1. Okay, so I get 83.9 degrees, or I get 90 minus 55.9, 55.9. I get 34.1 degree. Let's see, 34.1 degree equals theta. Okay, so that looks like the first 2 positive answers to me, but let's let n be 1, and that was 1. Let's let n be 2 now and see if I get the next 2 and see what I get. So I'll get negative 6.1 degrees plus 180 degrees, or I'll get negative 55.9 degrees plus 180 degrees equals theta. So I should get, well, you can see I'm going to get the next 2, but 180 minus 6.1, I get 173.9 degrees, and then 180 minus 55.9. So I get 124 or 124.1 degrees. Okay, so I'm really done at this point because I could see that I have the first three. So the answer here, I could do it just in a different color just to emphasize, but the answer here is going to be 34.1 degree, 83.9 degrees, and 124.1 degree. Those are the first three. Dot, dot, dot. It just keeps going forever. Okay, but that's the first three. Now, I just to completely overkill this, in case anybody, doubt anybody will be watching at this point, but in case anybody is interested, any of my students are interested, let me go ahead and graph this function. Remember what the function is and just show you what we're talking about here too, because sometimes it helps if you just see the graph too. Okay, so it's going to be y equals, remember we've got 2 plus the cosine of 3, amplitude of 3 there, 3 times the cosine of 4, 2, 3, 4. You can see Dr. Forrester has trouble making up problems the same as me. Theta plus 31 degrees. All right, so we can see the phase displacement. We could just see everything right there really easily, right? The sinusoidal axes. So let's just graph this real quick and see if we can get a sense of what in the world is going on here. All right, so the sinusoidal axis is at 2. So let me say like this is 1. This is 2. Did I make that 2? Maybe not. 1, 2, 3, 4. I don't know if I put it right there. I can't go up quite high enough. So let's let this be 1, 2, 3, 4, 5. We'll just count by that. 1, 2, 3, 5, 7, something like that. Okay. The sinusoidal, and then let's see over here, 31 degrees. Let's see, it's going to have a, let's think with multiplying the argument by 4, we can see real quick here that B is 4, so the period, right, is going to equal 360 degrees divided by 4, or it's going to be a periodicity of 90 degrees. So going through one complete cosine cycle every 90 degrees. So let's at least come out, I don't know, 10, 20, maybe like 30, 40, let's label that as 30 degrees, 30, I lose track on these, sorry. I know it takes me forever here. 1, 2, 3. 1, 2, 3, there we go, 60. 1, 2, 3, 90. 1, 2, 3, 100, 120. 1, 2, 3, 1, 2, 3. There we go. Okay, so 30, 60, 90, 120, 150, 180, 210, whatever. Okay, get a little bit carried away here. I hope that makes sense. Okay, so let's go with it. We're going to go with 2 is the sinusoidal axis. So let's just kind of come over here at 2, draw a little sinusoidal axis, and we could see that the amplitude, it's instead of the normal cosine function from up 1 down 1, it's going to go up 3. So 1, 2, 3. I kind of like thinking of it as I just saw Mr. Klein do this and thought, wow, this was cool. 1, 2, 3, and then go down 3. 1, 2, 3. So do you see it's going to be bounded in kind of by those boundaries right there? That's cool. All right, so it's going to go up 3, down 3 from the sinusoidal axis, y equals 2. And we can see that it's got a periodicity of 90 degrees, and it's going to be displaced 31 degrees to the left. So that's going to be out here. Let's see. It's right here, 1. So I'm considering it right here, the axes. So go back 1, 2, 3. So I think negative 30 degrees is about right here. So displacing at negative 31 degrees would be about right here. That's going to be cosine function, so that's going to be a high point, right? And then 90 degrees later, so let's see, 30, 60, 90 right here, is going to have another high point, which is going to be If it's negative 31 degrees, it's going to just be one degree before this, right? So 36, yeah, right here, that right there. Okay, then 30, 69, so about right here. And then, and about right here. All right, so those are the high points. That means the low point's going to be just exactly halfway in between. So here we go, and it's going to hit a low point about right, you know, just about right there. It's like the nose, right? Another little low point right there. Another little low point right here. Okay, so here we go. I always like to make these waves. This is so much fun. Whee! We're having fun now. There we go. Okay, now let's see if what we've said the answers were are anywhere near, there we go, 34.1. Let's look and see. Is that going to be our first positive place where, let's see, theta equals 1.5. So 1.5. Let's first of all think of where 1.5 is. Here's 1.5 right here. There it is, right, do you see? Right there, 1.5. So our first three values, look at right there. Cool, cool, just a little bit bigger than 30. That's not bad, 34.1. We're doing good. Uh-oh, let's see our next one. Oh yeah, no, this looks good too. Look right here, see? We said it was 83.9 degrees. Look, it's just before the 90. That looks like it could be 83.1 degrees. Sweet. Do you see what we're doing? We're finding the first three positive values. This one would work too, but that's just going to be a negative value right there. So that can't work. And then let's see this last one right here. What's this one going to be? 124. Yeah, look, see? 120, 124. Ooh, cool. 0.1 degrees. And you know, like I said, forget the, I don't know what Dr. Forrester did in there. That's what I do. There they are. Am I getting the same answer as him in example 1? Yeah, because I got negative 34.1. I know I'm right here. So whatever he got, this is the first three. All right, thanks. Bye.